So good morning, everyone. My name is Alan McKinnon. I'm a professor at the Kuna Logistics University in Hamburg. If you haven't heard of it, it was set up in 2010. It's 10 years old. We think we're the only logistics university in the world, and sustainability is one of our core competences. We're still very small. We've got about 25 professors and 300 students, but we are rapidly expanding. And as I say, we're based in Hamburg in the port district of the city. Anyway, I've got limited time. I have a lot to say, so I'm going to keep this presentation reasonably tight. I always like to begin my presentations on this subject by referring back to the climate science to remind everybody as to why it is we're doing all of this to try to cut carbon emissions. With an update on the climate science, because I'm sure you've seen all the reports on television and in the press. Almost everything to do with climate science is deeply worrying. The main trends and temperature and ice melt and warmth and all are all heading in the wrong direction and at an accelerating rate. So we have, as Shane said, an enormous problem to deal with here. Climate scientists these days think in terms of carbon budgets. It's the accumulation of greenhouse gases in the atmosphere which drive climate change, and they have defined the carbon budgets for a 1.5 degree temperature increase or 2 degree temperature increase. We're getting very close to exhausting the budget for a 1.5 degree temperature increase, as you can see in that diagram. In 2018, the Intergovernmental Panel on Climate Change estimated that we would have about 420 gigatons, that's billion tons of CO2 capacity left for us to stay with, to have a 2/3 chance of staying within a 1.5 degree temperature increase by 2100. Now we're currently emitting about 42 billion tons per annum, so the arithmetic here is rather simple. You divide 42 into 420, it would have given us 10 years in 2018, and we're now down to about 8 years. And if we continue emitting CO2 at the current level, then we will have exhausted that budget by the end of this decade. Okay, we've had COVID recently, which has resulted in industrial lockdown of the populations, and that has had an effect clearly on CO2 emissions. At the peak of the lockdown back in April and May, it's estimated that the daily rate of CO2 emission fell by about 17%. But if you look at that in terms of the broader trend, that was a mere blip. Economies around the world are now recovering. CO2 levels are again rising. And you'll see the current trajectory on that diagram. We have to get onto that green line, that 1.5 degree downward trajectory to get to zero carbon emissions by 2050, and that is going to be extremely difficult. Nevertheless, there's an increasing number of countries around the world that are declaring an ambition to be zero carbon by 2050 or earlier. I think there are currently about 10 or 11 non-EU countries, including the UK, and the EU itself has committed to make Europe the world's first zero carbon continent by 2050, and you can see that the Green Deal, which the EU declared in December last year, also relates to transport. The target is to reduce transport-related emissions by 90% between 2015 and 2050. But interesting, that was a 90% reduction and not a 100% reduction. Because what do we mean by net zero? I mean, net zero is a term that trips lightly off the tongue, but often people don't properly define what is meant. I've put on this slide what is the most widely used definition. It comes from the Science Based Targeting Initiative. This is what net zero means. It's achieving a state in which the activities within the value chain of a company result in no net impact on the climate from greenhouse gas emissions. This is achieved by reducing value chain greenhouse gas emissions in line with 1.5 degree pathways, as I said, and by balancing the impact of any remaining greenhouse gas emissions with an appropriate amount of carbon removals. Because obviously many companies will continue to emit some CO2, so they have to do things to compensate for that. There are various ways of compensating. One is to undertake what they call carbon insetting. where within the range of a company's activities, they do things that will actually remove CO2 emissions. We'll give them, if you like, carbon credits. An example of that would, in the warehousing area, Renus, which is a logistics provider, last year opened a distribution center in Tilburg in the Netherlands, which was a carbon negative building. It had 13,000 solar panels on the roof, which doesn't just generate enough energy to operate the warehouse, but also powers 750 houses in the surrounding area. So that's an example there for how a company can do things that give it these additional carbon credits. There's also carbon offsetting, which I think we're all familiar with, where you're paying somebody else to cut emissions on your behalf. And I think almost certainly what will have to happen is there will be government initiatives here to engage in what we call negative emissions. For the governments to be net zero, they will have to reforest much of our land. There are other things we can do, like the so-called BECS solution. We could do it mechanically using devices called carbon scrubbers. There's a green beach proposal using olivine rock to suck a lot of CO2 out of the atmosphere. But these will be done at a large scale, probably, and by governments. And the other definition is the word supply chain, because I mean, those of you working in this area will know that that's a broadly defined term. It includes things like procurement, product sourcing, inventory management, returns management, storage, and so forth. Obviously, if one is aiming to make one's supply chain zero carbon, that is a huge challenge. I mean, you would then have to do a full carbon audit of the end-to-end supply chain. You would have to factor in what we call the Scope 3 emissions from your companies who would outsource your logistics or suppliers from which you obtain products. That is a big exercise. It may be necessary ultimately for us to do that. For example, if we have to put carbon labels on individual products. But as my time is limited today, what I'm going to do is just focus on one of those activities, namely freight transport, to look at what we'll have to do to make freight transport net zero by 2050. Now, I published a book on decarbonizing logistics a couple of years ago, and it's really built around what I call my 10C framework for decarbonizing logistics. It's 10 English words beginning with the letter C. So I start with corporate motivation, because it's tough doing this, and unless there's a sufficient level of enthusiasm within a business, it's not going to be able to do it. Having done that, you then have to calculate your emissions to see where the emission hotspots are within your logistics system or your supply chain. Having done that, you'll then commit to targets for reducing those emissions. You can then consider all the possible options for decarbonisation. And in doing that, it's best not just confining your attention to those activities you directly control, but as I will say later, there's a general feeling that to achieve the necessary deep reductions in CO2 emissions from logistics, companies will have to share logistics assets. They'll have to increase the level of collaboration. Done that, the next thing is to do a cost evaluation, because obviously any company is going to try to decarbonize as cost effectively as they possibly can. And in the light of all of that, you then choose what would be the appropriate actions for the business. So there's no one size fits all here. One would obviously have to put together a package of initiatives relating to your product type, your customer base, your supply structure, and so forth. Maybe at that stage, companies should contemplate carbon offsetting. If they're not able to meet their targets by reducing their emissions, they may then have to engage in carbon offsetting. Having put the program in place, you then implement it, you cut your emissions, and you learn from that experience. And so my 10C is calibrate the strategy, because you then put in place feedback loops. In the light of that experience, you may want to modify your targets, you may want to change your cost evaluation, and so forth. So we've put in motion a learning process here, because this is iterative, and I think many companies are still at a fairly early stage in this process. But this is, I think, a good, sensible way to proceed. I'd like just to focus on a couple of those C's. One is calculate emissions, because when I first got involved in all of this about 12 or 13 years ago, there was a lot of confusion over how you should audit emissions from logistics. There were many different methodologies available, different reporting standards. Well, thankfully, things have much improved in recent years. There is an organization called the Global Logistics Emission Council, which has done great work in harmonizing the measurement and reporting of emissions. That has also included work done by Fraunhofer, which again provides advice on how you can carbon footprint logistics buildings, the warehouses. What has also happened is that many big logistics providers have developed capability to measure their carbon emissions, which is obviously benefiting those companies that outsource their things. But we have a long way to go still. Most of the emission data we have falls within what we call system boundary 1 or system boundary 2, either the direct emissions from the vehicles or maybe expressed on a well-to-wheel basis, taking account of emissions from the energy supply chain. But very few companies currently report emissions from vehicle maintenance operations or from the maintenance of infrastructure, or the embedded emissions in the vehicles at the point of manufacture, or even pushing the boundary out to system boundary 5, taking account of administration or IT or personnel related emissions. So we have a long way to go before we get a truly holistic measure of our carbon emissions. My second thing I'd like to focus on is targets. How do companies commit to carbon reduction targets? Most corporate targets are still carbon intensity targets, relating emissions to the level of logistical activity. But we really have to migrate to what we call absolute emission targets. It's not just emissions relative to ton kilometers or pallet kilometers. We really have to set absolute emission reductions. And to help with that, there's a global initiative called the Science Based Targeting Initiative, which works with companies. I think there are now about almost 1,000 companies are involved in this process, to relate companies' carbon reduction targets to the climate science and ultimately hit a net zero target. And another good thing here is that in recent years, some very big logistics providers have come out with very ambitious targets to cut their emissions, and DHL going to zero carbon by 2050, Kuehne + Nagel for their scope 1 and 2 emissions hope to be zero carbon by the end of this year. So those companies that are outsourcing their logistics to these big logistics providers to some extent can piggyback on these companies' targets. But just to consider the options that companies can deploy, a lot of work has been done on this. Almost everything we could do to cut carbon emissions falls into 5 categories. The first is just to reduce the amount of freight movement, if possible, by rationalizing supply chains, for example. Second is to shift as much freight as possible onto lower carbon transport modes. The third is optimize utilization of vehicle capacity. Fourth is to improve the energy efficiency of transport and also in storage. And then finally, to reduce the carbon content of the energy that we use in logistics. Now, in the case of companies in the cold chain, applying these various things is, I think, more difficult for companies in non-refrigerated sectors. For one thing, in terms of reducing the amount of freight movement, there's a very high growth in demand worldwide for refrigerated transport. I think it's currently growing at something like 6% per annum. In terms of modal shift, the railways have a relatively small share of refrigerated freight. I don't want to generalize too much, but I think most railway businesses are not particularly good at handling temperature control. The other thing on utilization of capacity, the temperature control constraints, it seems to me, can impose constraints on backloading and load consolidation. I mean, if it's ambient product you're moving, then you have greater pulling opportunities and load matching opportunities than you have in the cold chain. Also, in terms of energy efficiency, you've got the added complication of maximizing the energy efficiency of the refrigeration as well as the propulsion. And then finally, you've got the problem of all the fugitive emissions, the leakage of refrigerant gases, some of which have a very, very high global warming potential. I mean, some are 10,000 times more powerful at warming the atmosphere than is CO2. So the extra effort that you have to put in place about maybe switching to alternative gases. Just a general point on this, from all the work I've done over the years, it seems to me that many people feel the way we're going to decarbonize logistics is by applying technology or switching to alternative fuels. Now, no question, these things will make a huge contribution, but one mustn't overlook the fact that there are a series of other things that one can do to supplement that. And this is why I use what I call my rectangular onion diagram to show all the other layers, if you like, where we can apply. So it's to do with the maintenance of the vehicles and the equipment, where they're driven, vehicle loading, routing and scheduling, modal split I've mentioned, but also the configuration of our logistics systems and supply chains may ultimately have to change to drive down emissions. Because if we confine our attention to decarbonisation within those inner layers, what that will do is reduce emissions per vehicle kilometre. But all the projections suggest that total vehicle kilometres are going to rise very steeply. So in the end, total emissions would rise. It's only if we apply initiatives at the outer layers of that diagram that we can reduce total vehicle kilometres, and that would then allow us to reduce emissions overall. And just to get a sense of how hard that is going to be, one can construct scenarios. So this is a scenario which looks at the different levers that we can pull to try to drive down CO2 emissions from freight transport. So in this first scenario, let's imagine that we transfer about a third, 30% of road ton kilometres onto the railways. And in the meantime, the railways improve their carbon intensity by 80%. We also raise the efficiency of the routing of the vehicles by 25%, 30% improvement in average load factors, 30% reduction in empty running of the trucks, 50% improvement in truck energy efficiency, and a 60% decline in the carbon content of truck energy. Factoring all of those things together would deliver a 90% reduction in the carbon intensity of transport. Now, those of you who work in this area know how hard it's going to be, how formidable a challenge this is going to be, even over a period of several decades. That's only one scenario. I mean, we could rely more heavily on reducing the carbon intensity of energy, which I'll talk about later, maybe moving to hydrogen or battery power. And that would take the pressure off us to do the other things. But the other really big challenge that we have is doing this quickly. Because what this graph at the bottom shows is the amount of CO2 we will emit if we peak our emissions, say by 2025, and then have a more gradual decline in emissions thereafter, or if we don't peak until 2035. In both cases, we would then be diverted from the business as usual trend, as you can see. But remember I said earlier, it's the accumulated emissions in the atmosphere which drive climate change. Now, if we delay and don't see our emissions peak until 2035, then there will be an accumulation of about 1/3 more emissions by 2050 than if we do it by 2025. So again, it gives us an indication of the need for urgency here. Now, many people think the main way in which we're going to move to zero carbon logistics is by electrification and taking advantage of the decarbonisation of electricity worldwide. There was an excellent report on the cold chain published by the University of Birmingham last year called Doing Cold Smarter. This is a sentence from there. It says, there seems to be an implicit assumption around cooling that much of the heavy lifting of emissions reductions can be achieved through decarbonisation of electricity. And that is a widely held view across the logistics world, I think, as well. And what we then do is decarbonise electricity generation. We would then electrify as many logistical activities as possible, and then ensure that there's enough zero carbon electricity to meet logistics demands. Now, again, if you look around the world, there are huge variations in the average carbon intensity of electricity. Here in the UK, we come out of this quite well. We've got relatively low carbon electricity, and Britain is leading the world, I think, currently in the rate at which we're decarbonising our electricity. There's the projected graph for the UK to the mid-2030s, by which time we'll have the carbon intensity of electricity in the UK down to below 50 grams of CO2 per kilowatt hour. But remember, there are going to be lots of competing demands for that low carbon electricity. As we move to electric cars, for example, I think by 2030, they reckon there'll be 300 million electric cars in the world that will require recharging. We also have to move from fossil fuel heating probably towards the electric heating of our homes. So there's a question as to whether there will be enough zero carbon electricity to support the logistics sector. How we actually do this? Well, I mean, we already see extensive electrification of delivery vehicles at the local level in urban areas, smaller vans with a stop-start duty cycle, and no question, I think it's electricity, it's batteries that will do that. The price differentials narrowing between diesel and electric vehicles. The delivery range is expanding. We're seeing an expansion of the recharging network. The big problem is long distance trucking, where there's currently a lot of disagreement as to what the right decarbonisation pathway will be for long haul trucking. If one thinks of using batteries for that purpose, it's long been argued that the batteries would simply be too heavy and too big, and one would lose a lot of payload. But there's a dispute on this. Some people are still arguing that the battery would weigh, like in the US, a Class 8 truck. It might be a 10 or 12 ton battery you would require, say, for a 500-mile range. Others, like Tesla, for example, the Energy Transition Commission, suggest that with advances in technology, that we can drive down the battery weight to maybe 4 to 6 tons, and we can also accelerate the recharging of the battery, which would then make batteries a more viable option then for decarbonising long haul trucks. Many people, and an increasing number of people, however, are currently promoting hydrogen as the way in which we do this, using hydrogen fuel cells as our means of converting low carbon electricity into motive power. But again, there's disagreement. Some organisations, the Climate Change Committee in the UK is quite positive about this, various other organisations, but there are critics. Perhaps the main one in the UK is the professor in Cambridge University, David Seaborn, who argues very strongly that we waste a lot of energy in using hydrogen to decarbonise trucking operations. As much as 75% of the energy gets wasted, and arguing that low carbon, zero carbon electricity is going to be a precious commodity that we shouldn't want to squander. Others say that even allowing for those energy losses, it still makes sense to use hydrogen. This is becoming a very controversial subject. Some of you may have read in the Times last week. There was an article, there was even an editorial article about this, suggesting that we really ought to stop and really reconsider the benefits of moving to hydrogen in the trucking sector. The other option, of course, which isn't all that prominent here in the UK, but is developing elsewhere, is to electrify the highways, to allow direct transmission of zero carbon electricity into trucking. So there are trial schemes in Sweden, Germany, and the US. A lot of work's been done in Germany on this. They found that about 60% of CO2 emissions from trucking occur in only 2% of the road network. And even when vehicles leave electrified sections of road, most of them can access factories and warehouses within 50 kilometres. So you could then have a smaller, lighter battery, which would allow the vehicles to leave the electrified highway to access industrial premises. And a lot of positive research done in Germany suggesting that it would be cost effective to electrify up to 4,000 kilometres of the Autobahn network by 2020. So it raises the prospect, maybe in the future, we'll see the powering of truck refrigeration units in trucks from overhead catenaries. Or is that idea fanciful? The other thing we could do, of course, is just do what we can to reduce the energy consumption. And a lot of positive developments here, I mean, in terms of vehicle technology, with new build vehicles and also retrofitting them with aerodynamic profiling, for example. We've seen more and more governments around the world introducing fuel economy standards for trucks, only allowing their sale if they achieve certain fuel economy or CO2 standards. And it's not just the motive power, it's also the ancillary equipment, which is obviously particularly relevant in the cold chain. From what I've read, I mean, the refrigeration energy can represent 15 to 25% of the transport energy in a trucking operation. And many of you, I think, online will know more about this than I do, but obviously there's potential for improving the refrigeration efficiency of refrigeration units, better insulation, changing operational procedures, maybe switching to alternative refrigerants like liquid nitrogen and so forth. One of the most cost-effective ways of decarbonising trucking operations is to train the driver to drive more fuel efficiently, and then to use telematic monitoring to ensure that they continue to observe those good practices. Some people are also reckoning that tuning will make a contribution to cutting carbon, or even ultimately automating the vehicle, believing that computers will drive trucks more efficiently than the humans. And then we can change business practice. I published a paper in 2016 talking about deceleration, suggesting that in a low carbon world, we may simply have to slow things down to reduce the amount of energy that we use. And you know, there's a lot of evidence to show that if you reduce the average speed of the vehicle, you can again achieve significant energy savings. There's asset utilization, as I mentioned earlier, to fill the vehicles better. In the late 1990s, early 2000s, I worked with the predecessor organization of the Cold Chain Federation. It was called the Cold Storage Distribution Federation back then, on government-sponsored projects, looking at what we could do to improve vehicle fill in the sector. There are a whole series of reports you could still download. The work that was done back then, in fact, the last study was done in 2009, suggested that there was some underutilization of vehicle capacity in the cold chain. Unfortunately, I've not seen any comparable data for recent years, so I don't know to what extent that has improved over the past decade. But other things that we can do, of course, is relax truck size and weight limits to permit greater consolidation of loads. Again, I've been involved in research in this area to show that that there are significant carbon savings from increasing the size and weight of trucks. Though in the UK, you know, we don't necessarily have to lengthen them. We can raise their height. I mean, in the UK, I think about 20 or 25,000 double-deck trailers these days, some of which are refrigerated, which again have allowed us to consolidate roads and cut CO2 emissions. There's a general feeling that decarbonisation is going to require greater sharing of logistics assets, encouraging companies to engage in supply chain collaboration. This is some data from a study that was funded by the EU some years ago called CO3, which demonstrated that where companies share their vehicles, you can achieve substantial reductions in the carbon intensity of the operation. And taking this forward, that this is a bit more futuristic and a bit more visionary, but the belief that maybe we can establish what's called a physical internet, where there is much greater pooling of capacity across companies' supply chains, and that would again result in deep reductions in emissions by 2050. I don't have time to discuss this in detail. You'll have noticed that I've actually put in links in this presentation, and you can all get copies of this presentation to the sources if you want to pursue any of the issues that I'm raising here. And the other thing is the application of information and communication technology in a whole range of ways. And the belief is that all of these things, again, will help us to decarbonize logistics. So I'm talking about online freight procurement, data pooling, use of the blockchain potentially, smart road infrastructures, the Internet of Things. Nobody, to my knowledge, has yet quantified the combined impact of all of these IT developments, but there's general agreement all of these things collectively will help to drive down emissions. The other thing we can do, which I mentioned earlier, is switch freight to lower carbon transport modes, because the carbon intensity of rail, for example, or water-based transport is significantly lower than that of road transport. Here in the UK, we have the potential, obviously, to switch from road to rail. One of the key things here is the extent to which we can electrify and take advantage of zero carbon electricity. Now, in the UK, by comparison with other parts of the world, we have a relatively low level of rail electrification. And in the case of rail freight, it's only, I think, about 10% of UK rail freight which is currently electrified. So one thing that we need to do in the UK is increase that level of electrification. The other point I'll make about the UK is that the railways have been losing market share in recent years, partly because of the loss of fossil fuel traffic, of coal in particular, which was a core traffic of the railways. So again, the railways would have to reverse that if they want to increase their role in decarbonisation. The other thing is about the extent to which rail freight can contribute to decarbonisation. We'll need a number of other things. For example, changing the commodity mix, because as I understand it, very little refrigerated freight is currently moved by rail. There are some examples, but I simply ask what the prospects are for the railways undertaking more work in the cold chain as well to drive down emissions. And then I think this is my penultimate slide. The good news story here is that there are a great many things that we can do to decarbonize logistics, as illustrated in this diagram. These things vary in their ease of implementation and also the carbon abatement potential. The speed with which they can be adopted, again, varies a lot. But as Al Gore once said, we're not looking, there's silver buckshot here. There's a whole range of decarbonisation initiatives that we can deploy to try to drive down emissions. And I think that's something which one can say very positively about this. And then finally, I live in Scotland while I work in Hamburg. I came across this BBC News website recently where it said that with climate change, dry, hot summers are going to become quite common. And so in the light of this, please forget everything I've just told you about cutting carbon emissions. I'm only joking. Anyway, I've mentioned that I published a book on this subject, which is available. Those are my contact details. Again, if you have any questions you'd like to ask me, drop me a line and I'll happily respond. And I think I may have slightly exceeded my time, and I apologise, Shane, for that. But
no, Alan, no, thank you. A brilliant scene setter for us. And obviously, given this is the first of our 4 sessions on this issue, you've kind of given us a real kind of framework to think about a lot of the issues that we are going to be addressing through the next 4 weeks and beyond. Can I ask you just one question, Alan, before I bring in our next speaker? Obviously, you wrote this book 2 years ago, so you obviously were researching it before that. How do you feel, how optimistic are you about the level of awareness and grip that the industry has, the supply chain industry, logistics industry has, for the scale of this challenge?
I'm greatly encouraged. I mean, I think there is a lot of engagement with this issue now. Again, if one, how do we detect this? Well, I mentioned that there are now almost I think 1,000 companies engaged in the science-based targeting initiative. If one looks at the number of companies that are expressing a desire to be zero carbon at some point in the future, so a lot of indicators here suggest that there's greater and greater industry engagement on this subject, and more companies are coming up with carbon reduction targets. And that's going to change, really, I think, over the past decade. There are also so many initiatives worldwide promoting low carbon. You know, there's a Smart Freight Centre here in Europe, which is very strongly promoting this. So the question is all this going to be happening quickly enough? Because I think although are applying this, I do have some concerns about the rate at which it is happening. And there's also, as I mentioned, some fundamental disagreements on how we decarbonize on some of the issues that I've discussed. So I think we're heading in the right direction. The question is, will it happen quickly enough for us to stay within these very tight carbon reduction targets? Well.